Welcome to part 4 of Competency 10. In this video, we will answer questions relating to derivatives and trig functions. To begin, I wanted to make note of the primary derivatives of trig functions and the primary derivatives of log functions. We have them listed here. There's 6 for trig, 3 for log. Now, this is just what we're using in this particular video. As far as practice tests and real tests, highly unlikely you're going to see much more than this. Actually, I take that back. There will be one other trig item that'll show up in another section, which will be the double angles, half angles. But anyway, that'll be shown to you when it comes up. So if you want to pause the video, take a screenshot. Okay, let's move on. Number 1, if y equals cosine x over 3x squared, what is the simplified expression for the first derivative? Okay, well, we've noted before how to deal with these. Okay, what we will have is this. We will have the numerator first derivative times the denominator as is minus the numerator as is times the denominator prime or first derivative of the denominator. And then the denominator should be squared. Okay, so let's go look at our ABCD options. Now this is a little questionable because when I'm looking at these and I look at what we have, I think that we'll have a situation where some things can be, I mean, right off, you'd say, okay, B and C, they would check, and then A and D, you'd say, no, that won't work. Well, I'm a little suspicious of that. I think we should follow through and then just kind of see what happens and see if anything can be canceled. Okay, so let's try this out. So what do we have? We have y prime, first derivative, equals, okay. Now, because I'm suspicious that we might be able to cancel some things, I am going to write this as 3x to the second power times the 3x to the second, just in case. All right. Okay. I really think we're going to be able to cancel. All right, so what do we do now? Well, we need our numerator. We need the first derivative, and the first derivative of cosine x is negative sine x. Now that will be times the 3x squared. Okay, now we subtract the numerator as is, which is cosine x, times the first derivative of the denominator, and I see that that is 6x. Okay. Okay, so now let's rewrite. And I think this is when you'll see some things that can cancel. I see that we can pull out the, I'm not going to pull out the negative because I'm thinking we can cancel. So I'm seeing that we can pull out a 3 and an X. That's what I think we can do. So I'm saying let's pull out 3 and x, okay? So that means that's from both sides of the, I'm going to highlight this, the minus. On both sides, I'm pulling it out. Okay, factoring out that. Now what do I have? Well, I'm going to get rid of the 3, getting rid of one of those x's, and I'm going to get rid of this x, and this will leave me a 2. So I have to clean that up because that's very messy. Okay, so let's see here. I have an x right here that I can pull out here. So I have negative 3x minus 3x sine x. Remember, the sign with an x, they stay together. You can't factor out that x. Let's just say it's stuck to it, it's glued to it, however you want to put that, but they stay together, okay? All right, now, that's from the first side. So I have everything, and it's very messy. So when you do this, you have to be very careful. Okay, so I have all that. So I'm going to have my minus. Now, the cosine x, that guy's going to stay. And I need it to put that 2 in front of that. All right, now, below this, I know that I can pull out the 3 and the x, and that will leave times x times 3x squared. I'm kind of planning ahead. All right, so what are we really getting rid of? I'm getting rid of this 3x and this 3x, okay? So those guys are gone. So I can consolidate. Well, the first thing that I see is in that denominator, I see 3x to the third. Well, that tells us that B and C, if we would have went with our first intuition like we had done prior videos where it was so simple to see, we would have been absolutely incorrect. So always be wary. And kind of what let me see that was I was thinking of, well, what's derivatives and first derivatives? As far as the derivative of the denominator that we use. This right here. This fact right here kind of clued me in. You got to sometimes look ahead. Okay, so this means this guy is gone. Let me write this. This guy's gone. That guy's gone. First intuition, completely wrong. Okay, now let's go with for the rest of it. Well, what's left over? That's what we're doing. We're just looking at what's left over. It looks like everything else is clean. It's okay. So we just have the minus x sine x minus 2 cosine x. Okay, well, D won't work because the 3 was supposed to be canceled out. So that leaves us with the A option only. Okay, well, that wasn't too bad, a little messy. So if you had a hard time keeping up with me, go back, rewind the video real quick, and just go back through it. Okay, write it out for yourself. That's my suggestion. All right, so number 2. If y equals the secant x times 4x to the third, what is a simplified first derivative? Okay, well, there's a lot to unpack here. I see an addition situation because remember, this is your F and this is your G, and we have F prime G plus sorry. F as it is, F, then G prime. And remember, prime means first derivative. Okay, so the secant, okay, if we want the prime of the secant, that's secant x tangent x. Okay, so let's write this out. See if we can follow this. So that would be secant x tangent x, okay? Then g as is, 4x to the third. Then your plus. Then your secant x times the first derivative of 4x to the third, which would mean that is times 12x to the second. Okay. Now remember, we have to see what we can factor out from either side of that plus sign. Okay, so I'm going to use a different color here. So what numbers can honestly be pulled out? Or what items? Just items, not just numbers. Okay, I see that we have secant on both sides. That can be pulled out. We can, because this is the first part, it's all multiplied together, okay? So I see that we can pull out a 4 from both sides, and we can pull out the x squared, all the x squared. That means this will become 1 squared. So let's go ahead and do that. So what do we have? We have the secant x is pulled out. Actually, let's start with the numeric situations first. Let's start with our coefficient situations. Let's pull out our 4x squared. And when we do that, okay, let's do it first. Let's write it out. 4x squared, okay? So that means this 4 comes out, this guy stays, this 4 comes out, that becomes a 3, and that goes away, okay? Now let's pull out the secant. So from both sides, we have secant x, okay? So secant goes out, secant goes out. All right, so that's pulled out. So now what's left? Okay, here, actually, I wanted to change colors on all this so you could see what was pulled out. Oh, that did not help me at all. Okay, 4x squared. Now, what was left? Well, if you go in front, the only thing, oh, we have an x left. So that means we have an x. So that's x, x, tangent, x. Okay, so we had an x there in front. So now we've used this guy and this guy. Now we have to write our plus, go to the other side of the plus. What is left? A 3. That's it. Everything else is marked out. This 3 right here is the only guy left. Okay, so let's go to our options. Well, looks like A won't work because of this. Okay, because that should be to the second power. So this is gone. Now when we look at B, we're missing this x. So I'm not believing that. Then let's go to, looks like to me, option C. Well, option D won't work either because of the third power. So I'm looking at option C will satisfy what we have. Okay? All right. Let's move on to number 3. Number 3, if y equals 3 cosecant x minus 5 to the x power, what is the simplified expression for the first derivative? Okay, here's what's going on with this. First off, I can look at my options and already see that we have some problems that don't follow the rules. First thing that I see is that this situation is term by term. You take the derivative of each term, okay? Now, I'm looking at the second term of 5 to the x power. When we use our rules for the first derivative of logarithms for the natural log, is what that is, that does not change sign. So it cannot mysteriously become a positive in front of that because it's positive in its own right. Okay. So this means this is invalid and this is invalid. Okay. So I know to get rid of this and I know to get rid of this. So let me start this. Y prime equals. Okay. Now let's talk about the first term. In this situation, 3 is just multiplied to it. Okay. So we aren't, it's just part of the first derivative. Okay. It kind of goes along for the ride, let's say. The derivative that we need to focus on now is we need to find the derivative of the cosecant, which is negative cosecant x cotangent x, which you see in the option. Now, I just said that the 3 goes along for the ride. I want you to look at option D. In option D, they just mysteriously took the 3 that should have gone along for the ride and they just stuck him over there. No, we just don't move it around. That can't be done. Okay, so that is like not even following the rules of mathematics. Okay, so let's see what really happens. This is what happens. Technically, we have the 3 out here along for the ride, okay? And then we have negative cosecant x times cotangent x, okay? Then minus 5, we leave the 5 to the x power, and then we uh, multiply on what that first derivative, okay, the rules. We follow the rules. Let me say that. Well, if we're going to follow that, well, so that's ln 5, okay? So if we really want to clean it up and write it, look at option B. That's what we really are doing. So that should be minus 3 cosecant x cotangent x minus, and they use parentheses around everything. I agree. That's probably the best. So you see what things were multiplied together. Okay. And then they said 5x. I don't think I would have written that. It doesn't really matter at this point. We can see it. For me, my habit is to bring the ln 5 out here and then say 5 to the x power. But that's my thing. Okay. Either way, it doesn't matter how you write it. Okay. So we know option B is correct. All right. So let's look at number 4. Okay. All right. We can already see what 4 is going to be. All right. So start from the outside in. Okay. First it says if y equals sine 4x, what is the simplified expression for the first derivative? Well, if you're going to start on the outside, we need to look at the sine. Well, the derivative of sine is cosine. Okay. All right. All right. So C and B are incorrect because they didn't even get the cosine, the first derivative of the outside. Okay. All right, they just left sine, so that's not going to work. Okay, that being said, now we have A and D. Well, it's the outside in. Now we have to go to the inside. Well, what is the derivative of 4x? Well, that's just 4. So, but we don't rewrite this. What we're really doing is we're taking, okay, y prime equals, okay? So we take cosine and the 4x stays, okay? Then you're multiplying that times the 4. Okay, so the outside, then the inside. So the only one that works is option D. If you look at option A, it is tempting to select it, but it forgot about the derivative of, per se, the quote unquote inside, the 4x. Okay, so that's not an option. Okay, and then number 5. Number 5, it's going to get a little bit on the dicey side, okay? So if y equals the cotangent to the 5th of 5 minus 3x, what is a simplified expression for the first derivative? Okay. The first thing that we need to do now, remember, we're going from the outside in, and there's some things that are going to happen here. Let me start writing it out and you'll see what I'm talking about, okay? So what we need is y prime equals. Okay, if we look at the going out, the outside in, we have 5 okay? And then cotangent. Remember, leave everything the way it is first. And this becomes a 4. And then 5 minus 3x. Okay, that's the very outside, all right? Now we have to look at the cotangent. That we have to find the first derivative of the cotangent. And that is going to be minus cosecant squared, okay? Then we still leave the 5 minus 3x, okay? Actually, I'm going to put brackets around that. So you see that. Now, the very, very inside, we have to take care of that. And the 5 would be 0, and the negative 3x becomes negative 3. Now, this is the super dicey part. I know that you can see the chain rule and how we're going on the outside and we just go in, in, in. Here's the problem. When we start simplifying this, we have to be aware of what's actually going on. So I'm going to change my colors here. Okay, these brackets. Let me get rid of that bracket. I know I added it a second ago. I want to change colors so we make sure we're noticing them. Okay, now, if we pull the negative out, we have to remember that we have to pull it all the way out. Okay, so then how do I want to put this? Be careful. Okay, because if I just take this negative 3 and I bring it over here to the outside and make negative 15, I have to realize that this is what we really have here. You really have to think about this, and this is what's going on. Okay, we actually have here 5 cotangent 4. 5 minus the 3x. And let's condense this correctly. And this is actually minus 3 cosecant squared 5 minus 3. Okay, now I'm not going to lie to you. The only way I could prove this to myself and believe it was when I was working on these particular problems. I cleaned this up a little bit. I put this in to an online calculator and I worked with the negatives and the positives and understanding how it works and what we are actually multiplying. Okay. So now that I have it to where, because honestly, let's think of it like this. The 3x should not be outside that bracket. Okay. I'm going to erase it and move our bracket and our parentheses. Okay. The truth is, it should be here. And there really is only one negative. Okay. What we're really doing is putting the 3 there because we're pulling out the negative. We can't just say negative times negative is positive. Okay. So when we put it back in the brackets is what happens. Maybe I should put that back. And maybe double brackets is another way. I'm not sure. I had to work with it. That's what I recommend that you do. Well, let me see. let me say that we have super brackets. There we go, super brackets. So you need to look at it in that manner. But that's what it does honestly condense down to. Okay, now that I've talked to you about it in that way, okay, so what do we really have? We have negative 15, okay, and then we have cotangent for cotangent to the fourth, 5 minus 3x, and then another bracket, and that is cosecant squared 5 minus 3x. Okay, and which option is that? And notice that they are trying to fool us, and we know because if we looked at this incorrectly, if we didn't look at it as though we were pulling out the negative 3, then we would make the mistake of, well, first off, option C is the option we're looking for, okay? And it would be very easy to say negative times negative is positive, okay? Instead of seeing that we're pulling it out. And we would select D very easily. And then it's also easy to look right here and notice these two A and B aren't correct because obviously we can't leave the fifth power there. We had to apply our derivatives, our chain rule to get our first derivative. So those can't be correct. And let's see, it's D. D is the one that would really trip you up. Okay. Now, I also want to point something out that might make it easier in the end dealing with these negatives. There's a lot of ways to do it, and I'm not sure, which way is better for you. But here's another way to look at it. If we took the negative and we put it back in to each one, then we would have this 15 cotangent to the fourth. And then these in parentheses would become 3x minus 5 for each of them. You can only have one negative, and we had pulled it out. Now we're putting it back in. That's the tricky thing, okay? So that would be the cosecant squared, and again, that would be 3x minus 5. Okay? Now, I'll leave that to you. You can play with that and figure that out. Be careful when you're working with these. Now, I did not see this on a test, but that doesn't mean that they won't change it. Doesn't mean that a university practice test will not have it. It could definitely happen, and that little one issue with the positive and negatives could come up. Okay, this is our last question in this particular video. Sorry I rambled a little bit, but I hope that I'm at least helping you and helping you see things maybe a different way. And if you're having some issues, like you're a little tiny bit unclear here and there, I really hope I'm helping you guys out, okay? All right, and once again, thank you so, so much for watching. The responses are amazing. I appreciate you guys, okay? And don't forget, like us, share us, and subscribe. Happy testing.